Okay, so today's video is going to be a little different. How you might have seen, you might have known by the difference of the page or the notes I'm using. Today we'll be talking about geometry. Not normal geometry like what we do in maths class. We will be talking about geometry of uh, geometry of physics. Yes, as a physics student, everything should be in terms of physics. So, what will be our topic today? It will be about the orientation or rotation. Rotation. Okay, so let's suppose we have this circle. Okay, we have a circle, and let's suppose if I spin it. Let's suppose I spin it 90 degree. I spin it 90 degree. I spin it 90 degree. 90 degree. 90 degree spin. This is one spin. Let me change color for now because let me do differentiate. Okay, then I'm just showing you for now, then we'll talk about detail. This is 90, this is 180. This is 90 degree. No, not 90, 180. So, and then we go on to the second, then after this we have, we all know, this is 90, we should also have 0. There's one more which is 0, 0, and this one has 0. Okay, then the last and not least, but not least in our physics geometry, we have (170) spin. 170 spin. Okay, so when we talk, this is in, if I want to name it, this whole thing, it's called group theory. Okay, because group theory, we will be using this group theory, the degree rotation of 80, the degree rotation of 180, then 0 is first one, I should have put it in first one, then 270. We will use this for what? We will be using it for, first of all, let me go straight into this one. This is, we have what? This is a circle not particle. Let's suppose we'll forget particle for now. This is another shape. Well, let's put any shape we're talking about, and then we would have then we have what other yeah, then we have this one. Okay, so using this group theory, I will be defining, this is what we know, okay, this is what we call uh, state rotation. Okay, so if I spin this circle, okay, I'm spin this circle 90, 180, 270, there's nothing here, and 270 or 180, we will take 360. You might have noticed that no matter how many times I spin it, how it will always land up to its original position. Okay, so this is a, here we have no change in position, as it whichever direction I spin it or whatever degree I spin it will let me write this, will be in its original position, no matter the degree of spin, or degree of rotation. But then we have say different situation over here. Here, no change. Okay. Again, I'll rotate it. Look at that. Now at 90 degree, it changes position. Again, it changes position. Here, again changed. Here, came back to its original position. So now what do we say? Will take will be not wait sorry will be in its original in its well not original will not have original for now, will be in different form always mean with different rotation, it will be in different forms always. Okay, with every rotation we will have different form of this whatever the shape. Then okay, we come back, now we come to this rectangle. This rectangle is a little different. Let's put, if I put it like this way, let me put it in horizontal vertical. Okay, I spin it now 90 degree different, but if I spin it 180 degree, yeah, what happened? It came back to its original position. Okay, so what I want to say is that here will be in its original position with twice the spin. Okay, now I will be defining the same thing but using particles. Now physics starts. This dot particle, these are bosons or Higgs boson. This shape here, the triangle one, is gamma or light ray, and this here which represents this rectangle is gravitons. Now let's get into what I want to talk about using why I was talking about these three rotations. Higgs boson, no matter whichever direction you spin it, there will be no change of its position, either up, down, left, right, it will stay the same. But for gamma particle, or sorry, gamma photons, what it is, it's different. What happens, because with each change in direction there will be a different orientation. If I change it to up, wait, it should be like this, if I change it up, it will have a different orientation, left different, down different, right different. So each direction will have different position. As for gravitons, it only has two, either here, wait, yeah, either up or left, no other position. But here, so okay, now let me tell what I want to say. Higgs boson in vector form, again now let me talk about vector form, because this is where mathematics starts. but we will not have any equations of mathematics in vector form. We will focus on this vector. Okay, now let's focus on this vector. When I rotate this vector, no matter the rotation, nothing is happening to this particle. This particle over here, in whatever direction I spin it, no effect on the position or direction or direction. Okay, so this is a point particle. I think that's what we call a point particle. Then as for photons, it's different. We know that if photons are if the arrow is in this direction, photons are moving in this direction. If the arrow is in this direction, photons are moving in this direction, and this direction, and then this direction. So it has 4 different states. This one has 0 state, this one has 4 different states, 4 different positions, and this one has 2 different positions. So this takes 0 turns to come back to its original shape. This one, photons take 4 different turns to come back to its original position, and gravitons take 2 different turns to come back to its original position. Okay, as over here as well, if this is up, this is then second, and this is third. So at 1 2, only 2 turns. 1 2 sorry 1 2 3 4, 4 turns. 1 2 3 4, doesn't matter, 0 turns. Okay, so if I describe it in states, how will I describe it? I will describe it in, this is with, here it will be 1 turn for each change, and for photons, Higgs boson. Okay, so in terms of state, Higgs boson has state number 0, as there is no change in position or direction even if you spin it 360 degree. So it's Higgs boson. Higgs boson has this state. Then photons, since they take they spin with each turn, they will have photons will have state 1, but for gravitons it will have state 2, because it takes 2 turns, one here, then the second one to come back to its original position. It takes 4, but 4 with each turn, we cannot take it 1. Okay, so these are the states of but okay, we have notice the common factor. Here we will notice a common factor. Did we say that there is spin half? This one has spin full, this one has spin full, this one has spin full, this one has spin full. We didn't say anything about half. If this turns, there's a full turn, not a half turn. Half turn, if this is like, let's suppose these are, if someone turns from, if someone's going, or let me say if we have 2 directions, one here and one here, so when he turns, he'll do a full turn, so he will not turn half. What I mean by half turn is, if this is the road, he is traveling here, he will do a half turn. This is what we call a half turn, not a full turn. Okay, so this is for particles with integer spin, we call it spin. Particles with integer spin, but how can we describe particles with half spin? What am I talking about? For that, we have to go to my favorite theory or my favorite field, quantum mechanics or quantum, yes, mechanics. Because this will give us the key explanation to how spin particles work. Particles with half spin, and what are they? They are electrons or particles like it which make up what they make up the matter. Okay, so now how it works. For this we need to know something known as superposition. What is superposition? What is it? In being in multiple states at once. And now for this also for this half spin, I want to make an abstract space. Let me first of all describe superposition. Let's suppose we have head and we have tail. Head, tail. What are the chances in classical physics? What are chances of it being head and tail? 50-50, right? 50-50. In classical physics, yes, boy. Then, but what about quantum mechanics or in particular superposition? In superposition, we will be looking at each and every possible probability of having either head or tail. Let's suppose if I want to describe it in probability factor, it will be like this. Either it can have this, either it can have this, either this is full, either this, either this, either this, either this, either this, and so on. Multiple probabilities we can have. Okay, many probabilities. So this is what superposition is about, all about. Let's suppose we have H plus T, head and tails. Maybe it will be described by this, the great factor, and great factor it will be 3 and 2 as example. Okay, and then double head, double tails describe something else, plus minus, and it will be so on. Okay, so now use electrons, because okay, now electrons, this is an electron and its spinning means, as suppose I have electron, 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 electron. When I say it's spinning half spin, I mean if this is at this position first, initial. Half spin means this. Okay, this is half spin, then another spin, then another spin. So it's spinning like this as well. Over here it will be like this, 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 and this, so on. So this means quantum mechanics is this electron will need two turns. Two turns means 360-degree turn to get what do you say that, to get back to its original position. Okay, but this is not right in classical physics, as it says every object should come back to its original position with 360-degree turn. Classical physics says it should return in its original position in 360-degree turn. So how can we then, let's suppose, how can we do it? What we will do is we will consider that this spin, this electron, and I will make a abstract space for it. Spin. So we will consider that in this direction the electron turned again. It turned from here. It turned. This is 180. On the grid, it will be this, right? As we are talking about two turns. So then this 180 turn will be considered as this 180. So this 180 on the abstract space will be considered as 360 for the electron. But this is in quantum mechanics, we know that it's different. This part and this is a negative and this is a positive. So what we will do is that we will assume, we will be assuming something. We will assume that the negative of the abstract space will be taken as the original. In reality, in physically, I'm talking about physically, not mathematically. Not mathematically. Okay, this is key point. Okay, so this is a key factor I talked about, and it goes for every particle with half spin. Half spin. But in it's very tough when we assume it in three-dimensional, or when we assume it in different dimensions. Okay, and but over here, let me say, I will tell you how photons here are two-dimensional because of the polarization. Okay, polarization, because we know that photons or electromagnetic waves have vertical, which is magnetic, and horizontal, electric and magnetic. They have different direction, horizontal and vertical. Because of the polarization, it can cancel out vertical or horizontal. So that's why we have here, we say that it has four directions, or it's a state one. Okay, so quantum mechanics takes the distribution of the half spin integers in natural or real numbers plus in complex numbers. Like I'll show you 1 2 3 4 5 1 2 3 4 5, but as well as 1i, 2i, 3i. What are these? Complex numbers. What are these? Natural numbers. So that's how it makes the understanding of uh, the spin with the particles with half spin. That's how it describes it in vector form. Then I'm right here. Vectors. So yeah, that's it. Thank you.